The spin of an electron, the synchronization of cells, and the branching of a multiverse appear to operate under distinct sets of physical laws. The AE model describes these systems through recursive geometric structures called nested quaternions. The foundational object in this framework is the unit quaternion. It extends complex numbers into a four-dimensional structure constrained to a three-dimensional sphere. This equation tracks phase and coherence variables as they evolve, dictating the system's rotation rate through configuration space. This baseline rotation provides the foundational unit required to build the model's multi-layered architecture. To model a complete system, the AE framework divides its total state into four constituent layers: physical, etheric, astral, and mental. These layers form an inequality sequence where each field envelops the one below it. Every level maintains the exact same quaternionic structure. These are not physical boxes stacked inside one another. They represent a hierarchy of continuous mathematical transformations. Each layer maintains its own amplitude and phase, yet remains structurally bound to the levels directly above and below it in the sequence. Reality is constructed from these embedded informational states, where macroscopic structures are the result of these underlying dynamics. We must then identify the mechanism that allows structural information to move from the physical layer up to the etheric. This is handled by an interlayer morphism operator. It projects geometric information from a lower tier directly into the upper tier. This projection is governed by a coherence variable. It acts as a filter, determining if a configuration remains stable as it scales. Given the baseline rotation and the projection formula, how do you write the upper layer's dynamic evolution? Take a few seconds to deduce the result. By applying the chain rule, the fundamental rotational structure is preserved. The evolution of the upper layer is the original rotation weighted by the interaction between tiers. This coupling mechanism demonstrates that emergent systems are mathematically continuous with their underlying field components. We can apply this same logic to the largest possible scale, the branching trajectories of a cosmological multiverse. The A model uses this cosmological equation to describe the multiverse as a complex, branching quaternionic path. Notice the core variable here. Despite the complexity of the full equation, the primary driver is still the time derivative of a single quaternion. This card summarizes the framework, the fundamental object, the nested hierarchy, and the rules governing their evolution. These principles provide a consistent language for modeling reality, from the resonance of an atom to the geometric evolution of space-time itself.